Right. So the thing is like, so Dr. Hiran will cover the analog part, and I'm going to cover the physical computing part, right? So in this week, I'm going to do the physical computing lecture. Then the next week, Dr. Hiran will do the analog part. Like that, we'll switching each week and cover the your syllabus. Okay. Uh, right. So this is our roadmap for today, right? So first we discuss what is PC. PC means physical computing, right? Then why we need physical computing and OUN. Then we move on to the microcontrollers, right? So so the first one, what is meant by PC, right? So the PC it stands for physical computing, right? So that means we have like creating some interactive physical systems, right? So if we implementing kind of a website or something like that, so that is not a physical one, right? So we can't touch the website, right? So in here we going to develop some physical systems that interact with the users or the humans, right? So it can be software and hardware mix, right? Then it's sense and respond to the analog world. Analog world being the real world, right? So it's like like we want to uh, like change our like suppose we want to change our room temperature or the lighting, right? So if you need to sense the outside temperature, so outside lighting intensities, right? Then we can change the inside of a room, right? We can change the temperatures and the light intensities, those stuff, right? So every time we deal with the analog world or the real world, right? So that means we have, so why we tell identify it as analog world, right? So it is like a continuous one, right? So we have like everything is analog, right? So if you consider in the computers or something like that, so we have digitals, right? We have zero and ones, right? But in the analog world we have so many like a continuous states, right? So we going to sense those states on the outside world, and we going to respond, or we going to do some kind of action like rotating a motor, or like uh, powering up LED or something like that. We're going to again deal with the analog world, right? So then in physical computing we have two things mainly. We have sensors and the actuators, right? So the sensor is to sense the outside world, right? So we have sensors here, right? So this is the analog world, so the world we are in, right? So this is the reality, right? So we're going to deal with the reality, right? So it can be temperatures, humidity levels, light intensity, so like what else, like obstacles, anything, right? So anything, and ourselves, right? So we're going to sense the physical world, right? Then we're going to change these analog readings coming from the analog world into a digital readings, right? So suppose like we have a humidity or the temperature like 40 or something, right? So then we can sense it and display it in kind of a digital value in our physical, that computing system, right? So uh, that is the like a purpose of sensors, right? It always sense in the outside world, right? Then we, after we sense in the outside world, then we can do an action, right? So to do the actions we are using actuators, right? So it can be kind of a motor, so locker, something like this, going to do some actions or move some parts, right? So in the analog world again, right? So it's the sense in the analog world and do some kind of action on analog world, right? So that is the physical computing, right? So always we deal with the analog world, we going to finally at the end of the this lecture series, we can build kind of a uh, some kind of system, right? So that system we can touch that system, right? So we can that system can sense the outside world, and it can do some operations and tasks, right? Okay, so sensors like these sensors, as I said before, these are detecting kind of events or changes in the environment, right? So these are kind of sensors we have, right? So this is a kind of a humidity temperature sensor. We can sense the humidity levels of the air, right? Then we have this there are so many sensors, right? So this is just a kind of like overview, right? So just a rough idea, right? So then this we can use this sensor for sensing the gas, right? The air mixture, right? So do we have like suppose in kind of a smart home, something like that? So we can put this gas sensor, right? Then there are specific sensors to uh, do the sensing the several gas types, right? So if you want to sense the LP gas or whatever, then you can use that kind of a sensor to sense for gas leaks, right? Something like that, right? Then we have that sense the barometric pressure. Then we have sensors to find obstacles, right? So if we use this sensor, we can measure the distance through a obstacle, right? Then we have accelerometer and gyroscope, right? We can, by using this sensor, we can sense the what is the our like acceleration or the that orientations, those stuff. Then we have sensors like this. These are by, so this is the sensor, right? So you know RFID cards, right? NFC card, right? You can use this uh, if you travel on the highway. You can, they giving you this kind of a card, right? So you can, so there is a specific ID for that card, then you can, then they can track you, right? So like that, there are so many sensors, right? So everything you imagine, right, there is a sensor in our this Arduino, whatever the platform, right? Then we have these microphones, then the fingerprint scanners, then these two types of sensors to measure, like identify whether there is a human or like a human being or a life form in kind of a closed sit area, right? We can sense those things as well, right? So these are the sensors, type of sensors. We going to discuss these things in detail in the coming lectures. Then we have the actuators. So the actuators is the kind of like that do the action part, right? So that basically like a motor or something that moving some parts, right? So we have these servo motors or the stepper motors and these locers, then these actuators, right? Those are kind of actuators we can find, right? So these things, if we rotate something or do some movements, right, that's in analog world again, right? So we sensing some uh, parameters, so some properties in the outside world, right? Then we do some based on that sensing stuff, like if we sense kind of a gas leak, then we can do some like open all the doors or something like that, right? So you sense in the gas leaks basically, then you do some action, right, using these motors or those locals or those stuff, right? So is it okay up to now? Is it clear? Do you have any questions on up to now? Yeah. No.
No, sir.
Okay, right. Then why we need PC, right? So when we are attending kind of a lecture or something, right? So first thing we need to know is why we need to learn these things, right? So in the previous years, like in nowadays, so this subject was in third year, and that was a kind of a optional one, right? So if you like the subject, then you can pick the subject, right? But in now, so that is a compulsory one, right? So in that case, so even though you like or not, right, so you have to study, right? So I'm going to give some I'm going to influence you guys to study on this area, right? So there are about so in second years you can you have this electronic subject. Then again, fourth year you have embedded systems, and you can choose robotics, right? There are about 2-3 subjects you can pick on this your degree, right? So this is the starting point, right? So why we need PC, right? So because we can like we can create some tangible systems or the product that deal with the real world, right? Real physical world, right? So this is not the thrill we getting by making a website, right? So if you make a website that's working on kind of a computer, right, you can access it by, you can scroll it down or whatever, you can input, give some inputs like that, but that is not the physical one, right? So in here you can basically create some, it can be a robot or a kind of small flying objects like drones or something, right? There are so many things, right? So that basically we can touch and get some feeling, right? You can have a lot of fun in this area, right? So you just have to like get that influence, right? So there are so many things, right? So even you can this kind of a robots, like, so those things are very interactive, right? So you can like, so there is no limit actually, right? So if you think like, so your imagination is the limit, right? So you can, if you imagine anything, you can even in like I also tried once, like you can create even that like satellites as well, right? So there are no limit, right? So you can use this like Arduino, so whatever. So Arduino is a kind of just one instance of a physical computing, right? So I'll get into that later, right? So even using those very cheap items, very cheap electronics, you can do a lot of things, right? So there is no limit, right? So if you need more inspiration, so I'm going to uh, show you some video. Let me know when you guys, whether you can hear the sound. Okay, can you hear the sound? Can you guys hear me? Hello.
Yes, sir.
Yeah. So I'm having kind of a technical issue, right? So can you guys give me 1 second? So I'll leave it and come again. Okay. So my display is all black. So something with my driver, right? So you guys stay here, right? So I'll come again. Okay.